corrosie onder isolatie. Ik ga meteen even een presentatie met jullie delen. Om even de agenda kort toe te lichten. Kijk, ik hoop dat dit voor jullie te zien is. En ik wil even beginnen met de agenda voor het komende uur. Jullie zien trouwens dat alle tekst in het Engels is. We hebben straks ook een Engelse spreker. De introductie doe ik even in het Nederlands voor het gemak. Mijn naam is Rutger van der Maan, ik ben programmamanager bij KIK-NPI. Die organisatie zal ik zo even kort toelichten. Vervolgens zoom ik even in op het project CorrosieLABS. Dit webinar is een webinar in een reeks van webinars over onderwerp corrosie. En die horen allemaal bij het project CorrosieLABS. En vervolgens eindig ik met een kort reclameblokje over een aantal activiteiten van KIK-NPI. Nou, vervolgens neemt KAEFER het stokje over, Dr. Claire Watt. Welcome Claire, it's very good to have you in this webinar. Claire is integrity engineer en corrosie onder isolatie expert en is vergezeld door haar collega Ben Lodde. Ben is lead leader, onder andere een tipcheck engineer. En Ben is ook het aanspreekpunt van KAEFER als het gaat over het project CorrosieLab. Hij heeft ook een hele actieve rol in dat project. KAEFER zal beginnen met een kort filmpje over corrosie onder isolatie. Vervolgens zal Claire meer de diepte ingaan over dat onderwerp. En hebben we ook meteen even een Q&A. Dus als er vragen zijn, is dat het moment om ze te stellen. En vervolgens zal Ben afsluiten met wat meer informatie over KAEFER. En onder andere de rol van KAEFER binnen het project CorrosieLab. Huishoudelijke mededelingen. Ik kon daar geen Engelse vertaling voor vinden, dus ik neem aan dat iedereen ongeveer begrijpt wat ik ermee bedoel. Graag even jullie microfoons en camera's uitzetten. Weet dat dit webinar wordt opgenomen en dat de opname waarschijnlijk vanaf morgen al beschikbaar is op de KIK-NPI website. Even kijken, hetzelfde geldt voor de presentaties, zowel van mijzelf als van Claire als van Ben. Voor zover mogelijk. Ook te downloaden op onze website. En zoals ik net al aangaf, graag de vragen even achteraf stellen. Dat is wat handiger. Of tijdens de Q&A die we straks hebben. En vragen stellen kan via de chatfunctie of gewoon even live op het moment waarop we de Q&A hebben. Nou, ik denk genoeg even hierover. Een korte introductie KIK-NPI voor degenen die het nog niet kennen, de organisatie. Dus we zijn een kennis- en innovatiecentrum voor maintenance in de procesindustrie. En wat wij doen is het stimuleren, het faciliteren van samenwerking tussen bedrijven en het faciliteren ook van innovatieprojecten. Allemaal om onderhoud in de procesindustrie efficiënter en effectiever en duurzamer te maken. Nou, en die woorden zijn ook eigenlijk meteen onze innovatielijnen. Dus we hebben als een van de hoofdthema's circulair onderhoud. Dat is onderhoud op basis van de principes van circulaire economie. Dan gaat het over levensduurverlenging. Het gaat over het minimaliseren van grondstofverbruik, energieverbruik en dergelijke. Tweede is maintenance 4.0. Uiteraard afgeleid van industrie 4.0. Dan gaat het over de voorspelbaarheid van onderhoud en hoe je met data omgaat en dergelijke. En de laatste lijn is field maintenance. En dat gaat over het praktisch uitvoeren van onderhoud in het veld en hoe je dat op gewoon een efficiënte en vooral veilige manier kan doen. Nou, rond al die 3 lijnen hebben we een aantal activiteiten. En de belangrijkste activiteiten die we hebben zijn eigenlijk onze innovatieprojecten. Nou, CorrosieLABS is een van die projecten. Onze rol is om zo'n project te signaleren, er een project van maken überhaupt. En ook de uitvoering te begeleiden. Vervolgens hebben we ook een aantal fysieke plaatsen waar ontwikkeling en testen en validatie mogelijk is. Daar kom ik zo meteen even op terug. Dat doen we in het kader van maintenance 4.0-achtige toepassingen. Dus gaat het meer over robotica en sensortechniek. En ook in het kader van CorrosieLABS. Komt zo meteen al even aan bod. En de derde soort activiteiten, dus naast de projecten en de locaties, is netwerkvorming en kennis delen. En dat doen we onder andere door het organiseren van expertgroepen, webinars zoals dit, nou ja, en andere activiteiten. Nou, dat even in een vogelvlucht KIK NPI. Dan even inzoomend op het project CorrosieLABS. En misschien maai ik al wat gras voor de voeten weg van Claire en Ben. En ik begin ook met een open deur. Hè. Corrosie is een big issue in de procesindustrie. We hebben relatief oude installaties, assets hier in de regio. We hebben een zeeklimaat. Nou, dat helpt ook al niet. Dus met andere woorden, er is corrosie en het is ook echt wel een issue. Het heeft zijn weerslag op de veiligheid van installaties, beschikbaarheid en ook uiteraard op het milieu. Ja, en dat is eigenlijk de reden waarom er een behoefte is aan innovatie op dat gebied. En die innovatie kan zitten op het gebied van bijvoorbeeld preventie van corrosie, door coatings, door isolatiesystemen. Ook door het detecteren van corrosie. Hoe eerder je erbij bent, hoe minder kans op vervelende gevolgen. Door onder andere te meten en te monitoren, door inzet van robots om dat te doen. En als laatste innovatie op het gebied van het repareren van corrosieschade. Nou, die innovatiebehoefte is er. Aan de andere kant zie je met name vanuit de procesindustrie dat er, die zeggen van onze fabriek is geen proeftuin, dus we willen geen geëxperimenteer op ons terrein. Dus zoek maar een plaats waar je dan wel kan testen en kan demonstreren, et cetera. En dat is eigenlijk de aanleiding geweest van het project CorrosieLABS. Dus wat we gedaan hebben is 3 eigenlijk unieke locaties gecreëerd, of we zijn daarmee bezig te creëren. Eén bij de Hogere Zeevaartschool in Antwerpen. Dan gaat het over een ponton wat geschikt is gemaakt om corrosieverschijnselen in en onder water, de wind-waterlijn uit te voeren. 2 setups bij Scalda, de lokale mbo-instelling, gericht vooral op het onderhoud in de procesindustrie en situaties daar. En dan vervolgens hebben we ook nog CIRIS, die meer op een wat meer bij het wetenschappelijk niveau onderzoek uitvoert. En wat vind je daar? Eigenlijk realistische omstandigheden. Dus die de situatie in een fabriek nabootsen. En waar je dus testen kan doen met coatings, met sensoren, met allerlei andere systemen. En die nieuwe systemen, innovaties daar kan testen en valideren. Even in vogelvlucht, rechts, het is meer dan alleen die 3 onderwijs- of kennisinstellingen, moet ik zeggen. We hebben ook een aantal industriële partners aan boord, waaronder KAEFER. En het leuke is te zien dat er ook steeds meer zowel asset owners als onderhoudsbedrijven, als technologiebedrijven aanhaken. Goed, ik denk even genoeg over het project. Dit is even wat een impressie van wat er zoal gebeurd is tot nu toe. En we hebben nog even te gaan. Hè. Dit zijn echt nog prototypes van installaties. In het midden onder zie je van de Hogere Zeevaartschool op het ponton. Boven midden bij Scalda. En rechts meer de situatie bij CIRIS. Nogmaals prototypes. En we verwachten in de loop van het jaar, het einde van het jaar, dat we wat meer naar definitieve installaties toe gaan. Waarop bedrijven ook gewoon echt hun ding kunnen doen. Ik zou afsluiten met een kort reclameblokje. Nou, we hebben volgende week nog, op 8 juli, nog een webinar. Ook vanuit het CorrosieLab georganiseerd. Waar CIRIS en CUI presenteren. Dan gaat het over met name hoe je corrosiesnelheden kan meten. In de loop van juli, lanceerdatum nog niet helemaal bekend, komt de website live. Met veel meer informatie en ook projectresultaten en dergelijke. En in oktober is ongeveer de opening van de verschillende labs te verwachten. Tot zover even het KIK, NPI en het CorrosieLab verhaal. Laten we het iets interessanter maken en KAEFER het woord geven.
Good afternoon, everybody. My name is Claire Watt. Ben has asked me to introduce myself. I'm an integrity engineer working for KAEFER, and I joined KAEFER in 2018 to help develop expertise, innovation and training in the field of corrosion under insulation. I've got 20 years operational experience in upstream corrosion and integrity management. I've held staff roles within service companies, several international operators, and also worked as a consultant for a few years, providing quite a lot of CUI consultancy to different companies. And one of the reasons for this is that every job I've ever done has always, a large chunk of it has always involved sorting out some kind of CUI issue. So I've planned, funded and overseen execution of CUI improvement programs, field upgrades, design upgrades. I've provided consultancy, failure investigation, cold eyes reviews, and created strategies and risk-based inspection methods for managing CUI. I found my work within KAEFER pretty interesting. One of the things I've been working on is CUI data-driven innovation to improve prediction and understanding of CUI. We've got a couple of papers that have been published in this area, and I've also been part of a team working to put together an international CUI training course, which has so far been very well received. I've got a degree in materials engineering and a PhD in marine corrosion and hydrogen cracking. In 2010, ExxonMobil awarded me recognition of advanced professional development with specialist expertise in the fields of corrosion management, materials integrity and failure analysis, and corrosion prediction and monitoring. And just before ExxonMobil sold its UK upstream operated assets, which ended my time with them, I had been assigned the role of global CUI focal point, which would have been a really interesting job to do. But I ended up seeing enough of CUI from other companies subsequently. I've been a member of the UK Energy Institute Corrosion Management Committee for some years. I've helped to draft industry guidance. I'm a technical advisor to the UK CUI Forum. And I've been delivering training, corrosion training for 13 years now. I've been part of the Cranfield University training program to try and pass on industry experience to people who want to learn more about corrosion. Our corrosion under insulation masterclass training is endorsed by the Institute of Corrosion, and it's now delivered in a web-based online format, and we're hoping to hold another one later this year. And I don't deliver this course and create the content all by myself. I oversee it with a guy called Steve Patterson, who's my co-presenter, and Steve's a really experienced guy, and of course was materials and corrosion discipline head for Shell's upstream assets in Europe before he retired in 2017, and we were very keen to secure him to help with the training and also to help produce some of the papers. You'll see that he's a key editor in both of our published papers. So now, for your interest, we're going to run the pre-recorded paper that KAEFER delivered at the SPE 2021 Corrosion Conference, and it's called Using Industry Data to Develop Improved Methods to Manage Corrosion Under Insulation. It was pre-recorded, and I have added, at Ben's request, a few extra slides for your interest. The main reason for writing this paper is to highlight the need for better sharing and analysis of plant CUI data to gain confidence in the performance of different CUI technology innovations. And we believe this will be needed to achieve step change improvement. Industry has been insulating process equipment for 70 years now and innovating for 30 of those years. But the CUI problem still hasn't been solved to everyone's satisfaction, so it's pretty interesting to explore why it hasn't been solved yet. One of the problems is that real plants are, complex, congested, and contain lots of insulated equipment, components of which are all vulnerable to CUI in many climates. An onshore plant can contain up to 100 to 1,000 kilometers of insulated piping, as well as vessels, so that's a lot of vulnerable equipment. But despite this often large amount of vulnerable equipment, significant CUI is often highly isolated, and where it does occur, exhibits wide-ranging severity. So many plants that have fully stripped the insulation from all their critical equipment either later in life or sometimes following a big failure, often discover most of the equipment's in good condition. In other words, that it takes a significant inspection effort to prevent a handful of critical failures in a plant lifetime. And because we can't predict where and when significant CUI will occur, this inspection is resource intensive, so mean high coverage, conservative inspection intervals with a reliable technique such as removal of insulation. Preventing a few critical failures can, however, more than pay for this inspection effort. So it is ultimately often cost effective as well as obviously desirable from a process safety perspective and to avoid regulatory penalties. The knowledge, in fact, existed to prevent these recent critical failures that occurred over the last few years. But similar plants aren't all implementing the same inspection strategies, and this may have something to do with the fact that any regime can appear to be working for CUI for a very long period of time until a critical failure occurs. The isolated nature of CUI, however, provides a big opportunity to significantly reduce the cost of inspection, and this is what continues to drive innovation. So another problem is that it's not often made sufficiently clear that our CUI prediction knowledge comes from real plant data. Problem is that these data are not often widely shared. Only a handful of plant CUI data sets underpin our published and in-house guidance, and each new data set has revealed something new and useful right up to 2019. But they aren't fully characterized by enough variables and metadata, and there remain significant data gaps, such as critical failures, newer coating and insulation designs, and data from plants in different climates. So here are some examples of shared plant data sets. And you find yourself asking, what would this data look like for certain newer coatings or insulation system designs, or for different parts of the world? So the existing data sets that are shared all come from temperate, high humidity climates, but there are no data for offshore platforms, landlocked locations, arid climates, or those plants that are located closer to the equator in the tropics, where in high humidity regions, CUI could be much more severe for equipment operating at lower temperatures due to sweating. And one of the reasons why we are reliant on plant data for our CUI knowledge is that it's difficult to replicate CUI in laboratory testing, or so far it's been difficult. And this is because there are so many combinations of influential variables to consider when trying to recreate realistic conditions to realistically predict coating or insulation design or detection technique performance. So this is perhaps why so far real plants are our ultimate test rigs. So these photos all show some recent examples of laboratory test setups. They're a great start, but it's pretty obvious they're quite simple compared with real plant. So we're lucky enough to have a wide range of published CUI knowledge and guidance out there in the industry. But one of the difficult things for individuals coming into the CUI topic area is that this guidance isn't all, well, it's not apparent that it's in agreement. So also there's so much of it that you have to read all of it in order to distill out of this guidance a general consensus, and that general consensus is that prediction is limited by lack of data, and so conventional risk-based inspection methods still have to be conservative. So this is just an example to show that conservative CUI management can be cost effective, even though it's expensive. So this plant had 37 kilometers of insulated carbon steel piping, and it implemented conservative inspection. And during the first 30 years of operation, the data from this plant showed that it spent 10 million on looking after this piping, and that was mostly focused on 10 to 15% of the most critical equipment. And on the other hand, performing this inspection prevented 3 to 4 critical failures, which would have cost much greater than 10 million. So overall cost effective, though expensive. But we do wonder whether this is true for all plants. Putting all this information together means that there are some key challenges facing the evaluation of the performance of new CUI technologies, which impacts their integration into our day-to-day CUI management regimes. There's a wide range of innovative products and CUI solutions out there, and these can be divided into 3 categories: prediction, design, and detection. All these categories interact with and influence each other, so it's highly likely that industry will need to make progress in all these areas in order to move forwards. It's surprisingly difficult to measure what works for CUI because we rely on field data. It can take a long time to collect meaningful data, and perhaps that explains why the industry is still trying to understand the performance of existing products, some of which have been around for quite a few years. Currently, no technology has yet been proven as universally better at preventing critical CUI failures than conventional reliable inspection. So, for example, marine plants in a temperate climate might inspect their carbon steel insulated equipment every 6 years by periodically removing all the insulation, at least for the most critical equipment operating at higher temperatures. So in fact, all CUI technology innovations currently have limitations when compared with conventional techniques for CUI management. And the table in the paper provides an overview of some of these limitations for different coating, insulation design and inspection monitoring technologies, ranked against 6 categories across the top, A to F, developed to help summarize these limitations. A purple box indicates a known limitation, blank boxes, no information or no known limitations. And there are some key common factors that stand out. Some solutions aren't widely deployed, so they've not been given a chance. For example, drain holes, widely recommended in key published insulation design good practice, and yet they're hardly ever adopted. Where products have been deployed for long enough, such as superior coatings, closed cell insulation at higher temperatures, and others, there's a lack of shared data sets and also conflicting anecdotal experience, which probably both contribute to a general uncertainty in reliability or performance. And it's worth mentioning that there are other limitation types, such as application limits, cost effectiveness, or safety when using, which also drive the limited use for some of these products. So if we look at an analysis of 13 recent critical CUI failures, and critical CUI failures are not widely shared, and there are probably more, and these come from marine, onshore and offshore facilities in a temperate climate. The majority would have been prevented by using reliable inspection schemes that some plants are operating today. But failures continue to occur with newer coatings and insulation designs that are often promoted as beneficial for CUI and for which many operators take credit for in order to relax inspection. So is this simply a quality control or an application issue, or is it a fundamental limitation of some products that has been discovered in the field that could be avoided if better shared and understood? So there is an opportunity to improve the use of existing products before dismissing them due to isolated failures. So here are some examples of the limitations of some CUI design solutions. Hello, Brad Pitt, here representing the Greek warrior Achilles, and the definition of an Achilles heel is an often surprising weakness in an otherwise strong or powerful product. It's currently believed by the majority of organizations that a superior coating, such as thermal spray aluminium, a closed cell insulation, and a non-metallic cladding weather barrier all represent the best combined insulation system design choice to combat CUI. But if these materials aren't deployed correctly, then they can actually accelerate CUI and make it more severe than it would have been for conventional insulated systems. So for example, TSA is vulnerable to occluded cell corrosion, which can be initiated by applying a too thick sealer or top coat, or anything else that forms a tight crevice at the equipment surface. And as far as we're aware, it's only been reported for marine environments as chlorides are involved. Closed cell insulation might not absorb water, but water can still get trapped at the metal surface and cause CUI. And the use of adhesives to fix the first insulation layer can not only accelerate CUI, but also cause it to occur in unusual locations, which might not be detected by prone area inspection schemes. On the left, corrosion rates of 2 millimeters a year being reported, and on the right, maximum cumulative metal loss of 11.5 millimeters over 6 years in service. Finally, drain holes are especially important to apply for non-metallic cladding. However, we don't believe that any of these Achilles heels or the conditions that trigger them are sufficiently widely understood. But the good thing is they could all be avoided to maximize the value of these products, to slow down CUI, or at least not to make it worse. So I'm just going to, with this slide, click through some of the serious CUI inspection findings and failures that we're aware of that occurred over the last decade or so. And I'm going to try and speak about them in a general way while I'm introducing them to the slide, which is quite difficult. So the first thing we notice is that they occur for different temperatures, over different timescales, for materials of different wall thickness and different designs. And all of them relate to, or the carbon steel ones relate to failures that occurred or would have occurred after 10 years in service, a lot of them after 20 years in service. But to avoid economic impact, you often would have needed to inspect well before this. So that's why some inspection intervals are very conservative compared with the likely time to failure, or the realistic time to failure. Collectively, they do teach us to be very careful not to make too many assumptions when predicting CUI for highly critical equipment, whether it be associated with wetting, taking credit for different designs, or where the CUI will occur. For quite a few of these, there were no visual signs of CUI before removing the insulation, and many occurred in locations that considered as lesser prone areas, which might not be inspected by some company inspection schemes. So API 581 estimates, however, could well double the CUI timing experience if the plants were located in a landlocked area compared with these marine onshore offshore examples, which I find that really interesting. There are a couple of examples on this slide of to demonstrate that low pressure equipment can actually fail during human interaction, either the process of inspection or, for example, operating a manual valve. And there's a valve that failed on operation, released 20 bar of critical inventory, which is not a very safe thing, and resulted in a regulatory investigation. Other consequence of failure, surprises, there's always an exception. Sometimes we think that stainless steel fine cracking or pits, tiny pits, have lower release rates compared with carbon steel failures. But in 2017, this UK failure released 17 tons of ethylene gas very quickly. It actually occurred after only 1 year in service, and that's another issue really, is that periodic inspection is not really going to be effective at preventing the first stainless steel failure. So really the best control we have to prevent stainless steel failures, or the first failure from being a surprise, is well, to coat it and then periodically reinstate the coating. And this is why water monitoring is particularly interesting in the future for stainless steel systems, because inspection isn't really very effective. And there are some other examples here teaching us the lesson that sometimes just picking up the phone and having a 10-minute transfer of knowledge conversation could have saved a lot of trouble. And that's associated with this recent column ring failure, and also the BP safety alert that was issued in 2010 to tell the industry that TSA was an unsuitable coating under insulation. But it depends what specification you're using. We're still getting TSA reported issues today, but it would be really good to confirm that these are QA/QC or occluded cell issues that we can learn from and avoid. So it would be great to have more of these failures reported and logged in a database and compared with general good performance in order to perhaps do some more effective prediction. As I indicated previously, there is potential to improve CUI prediction by sharing more plant CUI data. This is just an example only, but here's a set of real CUI data: metal loss in millimeters versus time in years. And this applies to carbon steel CUI failures or inspection findings. There's no key, so you don't know what it means. That doesn't matter, because I do. The blue and green data shows that CUI proceeds much more slowly for equipment operating at lower temperatures, that's ambient and below, compared with higher temperatures. But whichever way you draw lines through this data, there are significant outliers for each temperature category. And if we knew more about the background metadata, we might be able to identify common parameters to target where to inspect for particularly severe CUI. And we could also then optimize inspection timing or even locations for the rest of the equipment using temperature, geographic region, or even design difference metadata between data sets. This hasn't been tried yet, but there are projects that are being set up to give it a go. It could be really promising. So non-destructive detection techniques also have limitations, and some of the most promising for carbon steel insulated equipment are real-time radiography, pulse eddy current, and sniffer dogs. Real-time radiography has been widely used in America for many years now with positive results, but not in Europe, where radiation exposure safety concerns are different. Pulse eddy current has the advantage of being able to be applied to vessels as well as piping. It's still expensive, but often faster than insulation removal and reinstatement, which makes it really attractive for offshore assets where bed space is at a premium. Sniffer dog technology, pioneered in Norway, has shown great promise, but there is a need to train the dogs for each plant with gas samples taken from systems with active CUI, which is quite difficult to organise. The big question is, will they detect all significant CUI defects? And in fact, because of the way they work, they all need trialling on real CUI defects and corrosion product. There might be some useful data that can come from laboratory simulated defects, especially for pulse eddy current, but ultimately the best way to evaluate these techniques is to deploy them prior to large insulation removal programs, although this increases the cost of an already expensive exercise. I'm not aware that it's been done. RTR and PEC do have application limits, so means they can't be used for all equipment. And that means that to achieve sufficient CUI inspection coverage, mixed technique inspection schemes are required, and this could be quite difficult to control. So this brings me on to the emerging embedded sensor market, which is evolved rapidly since 2016. It's the new big thing to tackle CUI. And that's because permanently installed sensors have the potential to locate where significant CUI could be occurring before it reaches the stage where it causes problems. And there are lots of different technologies. One is ahead of the others in terms of commercial deployment, but there are many with widely different approaches becoming available for plant trials. So on the one hand, this type of technology could work really well, providing email alerts to operators or inspection engineers, indicating locations in the plant where there is excessive water and humidity in the insulation system, or coating degradation, or even corrosion of the equipment surface. But we still don't know, on the other hand, how the data will look and how to use it to best advantage or to deal with false positives. One thing's for sure, they will all need plant trialing and testing. So the industry is responding to this CUI challenge to understand the performance of different CUI technology solutions in the fields of coatings and insulation, sensors, detection and prediction. The paper illustrates the various initiatives that are ongoing in the world in each of these areas, and some that stand out are the NACE, or now AMP, Task Group 516 initiative to standardize the CUI qualification testing to compare different coatings. The HOIS Joint Industry Project, recently completed in 2020, evaluated different non-destructive inspection techniques for CUI, and there's a very informative publicly available report. The HOIS is now running a new project to understand more about PET capabilities specifically. SINTEF has kicked off a 3-year Predict CUI project to understand more about water and vapor movement within insulated systems. The goal of this is to try and make plug-in humidity sensors work, which would be great for brownfield assets because you don't have to remove the insulation in order to deploy such sensors. DMV in the field of prediction has done some excellent work in publishing the first publicly available, simple, full CUI RBI risk management methodology. Can you believe it's taken so long to put something like this in the public domain? And it's a big step in the right direction, but still qualitative, and therefore could still over or underestimate CUI. Generally, it's conservative. There are plant CUI data collection projects afoot to train predictive models, Curtin in Australia, and a proposed UK project to collect CUI data on a large scale, with the various private projects completed in this area reporting success, but not widely sharing the data. In summary, there's a lots of good work going on, but it all requires funding, and we hope that the technical learnings could be shared in a coordinated way. So to summarize the key messages from this work, CUI causes localized, high-consequence failures, which are mostly preventable by adopting existing reliable inspection techniques. But improved knowledge share would help to align on what reliable inspection really means, and this could differ for different plant types in different locations. It can take a long time to prove CUI technologies because they have to be validated in the field. An improved plant CUI data share where they have been deployed would help improve confidence in their performance. Detection techniques could be proven more quickly by targeted field tests, laboratory tests, and deployment prior to 100% insulation strip programs. But ultimately, operators and plants have a really important role to play in sharing CUI data and investing in effective field trials. This could be argued as just as important as the development of the actual technologies themselves. If this can be done, then the next 3 to 5 years could yield some real step change improvements. The big question is, can industry create a framework for coordinated, anonymous, quantified CUI data share? Because without data, it's just another opinion. And an opinion really isn't good enough to try to prevent highly critical CUI failures, which can have big safety and economic impact on an asset. In fact, there are a lot of CUI forums that exist or are being set up in the world today, which allow people to share ideas and best practice in an informal way. But this, so they're in Norway, the UK, and EFC 15 is starting an initiative for Europe. But this isn't the same as quantified CUI data share. So thank you very much for your attention, and I hope you found the content of this presentation interesting. I'd just like to acknowledge the help of Patrick Barthold and Thomas Rayberg in producing this paper, Neil Wilds for sharing experience, and of course KAEFER for permission to publish. I really look forward to your comments, opinions and questions. So stay safe and goodbye.
Thank you very much, Claire. I've seen that there are several questions asked in the chat function, and that you've already answered, I think, most of them.
I think all of them, yeah.
All of them, all right. If there are any questions for Claire or Ben, now is the moment to ask them, or comments or remarks. Feel free to ask. Marcel, je kan je vraag denk ik ook even live stellen.
Gert.
Yeah, I was waiting for Marcel to put this question, but I was wondering what I'm still missing the risk perspective in the whole overview. I also commented in that in the blog or the message when you are discussing whether it's adequately managed. Of course, you need a reference. When is it? What is adequate? When is it sufficient? So I think the only way to get out of this is by starting with the risk perspective. So, and then for that, of course, you then need a generic approach over industry, because every company seems to have its own perception on risk analysis. And for that, I would assume that everybody then has a look at the EN 16991, this European guideline for risk-based inspection, which also contains risk analysis, and you should have that as a framework. And within this framework, then you can decide, okay, here are some things which sound good, these should be managed. Others, which then are still in agreement with your acceptance criteria, they don't need any additional measures. So my point is, where is the decision criterion risk analysis in your whole overview?
Well, it's different for every company because you know, it's a company determined risk acceptance criteria is a specific company determined thing. And one of the things that I think is lacking is there's really nothing in the public domain to assess consequence of failure for equipment. So one of the best consequence of failure assessment methodologies I've seen is ExxonMobil's, and they have a consequence assessment process which they established to generate consistency in consequence of assessment, consequence of failure assessment of equipment. But it might differ for different plants. Some companies literally just rely on their corporate risk tables, which don't provide enough information to enable consistent consequence of failure assessment. And so that's really critical because our prediction is quite limited for CUI. So really critical equipment, so pressurized gases and volatile inventory or high H2S or toxic inventory, you know, it's sometimes, I've seen it, it's sometimes difficult to represent this as the highest priority when integrity engineers are applying risk assessment or consequence of assessment analysis by themselves without the help of process or operations engineers. And then probability assessment methods, they're all very different. We'll try to send you, issue you all with a copy of our Eurocore 2019 paper, where I reviewed a lot of in-house and published risk-based inspection methods. There's no consequence guidance out there, really, no simple consequence of failure guidance, but there is a lot of probability assessment guidance, and some of it takes credit for factors that we have no data on, no supporting data. It's estimations or estimations, not proven by data. So some of the best methods that I've seen are those which actually try to predict the least and avoid making assumptions, at least for the most critical equipment. And because CUI is so isolated, or serious CUI is so isolated, one can often do a lot less inspection and take more chances on a lot of the lower consequence of failure equipment inventory. But I've seen some really serious accidents and issues occur, which were all near misses. I don't think anyone's been killed yet by CUI, but there have been a lot of near misses. So ultimately, you make a very good point. Why aren't we all aligned? I don't think we should be all aligned. I think different plants are suited to different CUI management regimes, but we don't really have enough data behind our experience to support that.
I completely agree that different plants require different CUI regimes, of course, but I think the key point is that if you are unsatisfied, if you think this CUI is unsatisfactorily managed, difficult word, then this requires a benchmark, which is then the same for every company. Because otherwise, you always have that one company says it's good, it's adequately managed, and the other one says, because they have different risk approach, they say it is ineffectively managed.
Geert, sorry to interrupt you. We don't have time for a very lengthy discussion at the moment. I'm very sorry. We have, in fact, 3 minutes left in our meeting, and also Ben has a part of the presentation that he wants to do. Are there any other questions for the moment?
There are a few, but I can pledge to answer them offline. Right.
Okay. Yeah. And we will also share your contact data, if okay with you, of course, on our website. So if you want to contact Ben or Claire directly, or maybe through Ben, but that's something we can arrange later on. They are available for questions, obviously.
Yeah, we answer all questions.
Yes, thank you. If there are no more questions at the moment, then I would like to invite Ben to present a bit more about KAEFER and their role in the Corrosion Lab project.
Yes, so thank you.
Thank you.
Zo, zoals beloofd ga ik nu verder in het Nederlands. Ik wil een presentatie laten zien over KAEFER in het algemeen en de rol die KAEFER gaat vervullen binnen het CorrosieLab. Ja goed, daar ga ik het een en ander over vertellen nu. Ik wil wel even de opmerking maken dat foto's die we zien in deze presentatie kunnen gemaakt zijn voor maart 2020, dus ook voor corona. Vandaar dat je soms wel mensen ziet die wat dichter op elkaar staan dan de social distancing op dit ogenblik verlangt. Wie is KAEFER? Nou, daar hebben we een heel mooi company profile filmpje voor.
We work on projects that count for our clients, our people, and you and me. From power plants and pipelines to ships and offshore platforms, refineries and mines, to tunnels and buildings. Whether you can see it or not, whether above ground or below, whether it's close to you or far away, all of the things we do make a difference.
We're the ones people count on.
The thermal, cold, cryogenic installation. We are the ones responsible for safe access solutions
And passive fire protection.
We are the ones who protect surfaces, outfit interiors,
And provide mechanical services that maintain the performance of our client sites.
we're efficient and reliable.
And we look out for the health and safety of one another.
We are the people you can count on to get the job done.
Even in the most challenging environments.
We're proud of that, but we don't stop there.
Every single member of our international family
Is driven by the spirit of continuous improvement. Because we care.
because we work on projects that matter.
Because we're KAEFER. When it counts, count on us.
Nou, prachtig wervend filmpje waarin dat we eigenlijk willen vertellen dat wij als KAEFER een grote familie zijn. Die alles bij elkaar meer dan 20 talen spreken. In meer dan 30 landen vertegenwoordigd zijn. Met meer dan 50 nationaliteiten. En we zijn nog steeds eigendom van één familie. KAEFER is dus daadwerkelijk nog steeds een familiebedrijf. En dat doen we al een poosje. Meer dan 100 jaar bestaat KAEFER inmiddels. Waarin dat we in 1918 is KAEFER begonnen met het isoleren van koeltanks op schepen. En dat deed hij vooral met gebruik van turf. Dus turf werd als isolatiemateriaal gebruikt. Nou, we zijn een eind opgeschoten inmiddels. De stappen doorlopen. We hebben natuurlijk de oorlog. Net na de oorlog sterft KAEFER. Maar Peter Koch was toen al partner van Karel en neemt eigenlijk het stokje over. En de familie Koch is nog steeds eigenaar van KAEFER. In 1955 heeft KAEFER al een aantal vestigingen in Duitsland en wordt eigenlijk groter en groter en gaat zelfs de grenzen over, de Duitse grenzen. In Finland is de eerste buitenlandse vestiging. Daarna volgen de vestigingen in Spanje, Nederland, Benelux, België uiteraard, dus, Australië, Zuid-Afrika enzovoorts. In 1970 is Dow in Terneuzen al een poosje bezig met het opzetten van hun fabrieken, maar in 1970 wordt de eerste bouw van de cracker gestart. En daar is de firma IIG, dat staat voor... even scrollen, dat staat voor Industrie Isolering Gelsenkirchen. Die heeft die klus aangenomen als isolatiepartij en heeft daarvoor als lokale partner WKS gekozen. WKS en KAEFER worden later ook één. Goed, hoe is KAEFER opgebouwd? KAEFER is opgebouwd met een board. In die board zitten twee heren, Dr. Roland Gerber en meneer Steen Hansen. Die beide vormen dus de opperdirectie, zullen we zeggen. Alle landen die je hieronder ziet, of delen van de wereld, die rapporteren rechtstreeks hun nieuws. En rapporteren rechtstreeks aan die twee heren in de board. Nou, waar kun je allemaal op rekenen als je voor KAEFER kiest? Wij hebben een stijgerbouw, isolatie, surface protection, lichtmechanisch werk, fire protection. En dit is ongeveer 75% van alle werkzaamheden die we doen. Op deze slide kun je zien wat die andere 25% onder andere zijn. En waar kun je ons vinden? Nou, je kunt ons vinden op energiecentrales. Wat doen wij daar? Natuurlijk rope access, isolatie, stijgerbouw, tracing, stoomtracing, elektrische tracing, etc. Je kunt ons vinden op raffinaderijen, maar niet alleen op raffinaderijen, maar eigenlijk in de hele procesindustrie, waaronder de voedingsmiddelenindustrie en de farmaceutische industrie. Voedingsmiddelen, denk bijvoorbeeld voor Nederland aan Friesland Campina, waar je yoghurt en waar je melkjes vandaan komen. Farmaceutische industrie, MSD Boxmeer, waar diergeneesmiddelen worden gemaakt. Zoals in het filmpje al te horen was, kun je ons vinden in de mijnbouw, nou, vooral in Zuid-Afrika. Offshore, vooral een afdeling voor KAEFER Noorwegen, die is daar heel actief in. Scheepsbouw, zoals we ooit begonnen zijn, maar nog steeds bouwen wij complete interieurs in cruiseschepen, bijvoorbeeld de Maienwerft in Papenburg. Dus bouwen, tunnels. Het kan zomaar zijn dat wij complete lobby's van ziekenhuizen hebben uitgerust. Hotels van binnen compleet hebben ingericht. Dat zijn ook werkzaamheden die door KAEFER worden gedaan. Kortom, heel veel takken van sport. Laat ik deze foto nog een keertje zien. Maar nu gaat het eventjes over die grijze balk bovenin. Corporate functions. Onder corporate functions vallen onder andere health and safety, operational excellence, waaronder bijvoorbeeld Lean valt, maar ook CEA, en dat is Corporate Innovation and Technical Excellence, met het stukje technical support erbij. Maar wat bedoelen we daarmee? We hebben in onze hoofdkantoren in Bremen hebben wij eigen laboratoria. In de laboratoria worden tests uitgevoerd op het gebied van materiaaltesten. We hebben klimaatkamers, we hebben akoestische ruimtes. We hebben eigen testleiding achter ons gebouw lopen, waarin dat wij middels hete olie een heleboel testen kunnen uitvoeren. We hebben akoestische services, zoals ik net al vertelde. Dit zijn een paar leden van het team wat in Bremen in het laboratorium werkt. Waar hebben jullie wat meer mee te maken? Jullie hebben meer mee te maken met KAEFER Benelux. We hebben een hoofdkantoor in Dordrecht. We hebben pak een beet 950 laborers aan het werk in de Benelux. Nou, sinds 1973 zit KAEFER eigenlijk al op de Terneuzen en we zijn eigenlijk nog nooit van het terrein afgewezen. Waar houdt KAEFER zich mee bezig in de Benelux op het gebied van innovaties uiteraard. Bijvoorbeeld de eerste safety street die daadwerkelijk is gebouwd, is op de terreinen van Douw geweest. Het was een collaboratie met BIS. Een safety street waarin personeelsleden heel interactief kennis konden maken met alle facetten waar ze in hun dagelijks werk mee te maken gingen krijgen. Nou, dat vonden wij een dusdanig interessant verhaal dat wij een digitale safety street hebben gemaakt in virtual reality. Met zo'n bril op is dit een van de ruimtes waar je doorheen kunt bewegen. We hebben meerdere ruimtes waar je ook een hele vergunningenprocedure kunt doorlopen en dergelijke. Op dit ogenblik zijn we heel druk bezig met digital scoping. Dit is niet uniek van KAEFER, dit is een verhaal van Schwartmans. Schwartmans is een van de machineleveranciers in de plaatwerkerij. En die hebben een programma ontwikkeld, ISOConnect, waar wij ook druk mee bezig zijn op dit ogenblik. Om in het veld op een eenvoudige manier digitaal de tekeningen te kunnen maken. En die in één keer door te sturen naar onze werkplaats. In die werkplaats hebben wij een tweetal lasermachines en die kunnen eigenlijk vanuit die tablets al worden aangestuurd om de prefab te snijden. Dus dat is een vrij unieke ontwikkeling waar we op dit ogenblik mee bezig zijn. Nou, komen we eindelijk bij het CorrosieLab. Dus ik heb de vorige slides zo snel mogelijk proberen door te gaan. Wat doen wij als KAEFER binnen het CorrosieLab? Nou, we zijn een volle partner. Vanaf het begin van het CorrosieLab zijn we erbij betrokken geweest. En waar wij daarin kunnen betekenen is vooral het leveren van isolatiemateriaal, het leveren van isolatieskills, know-how. En wat wij willen is eigenlijk het testen van verschillende isolatiemethodes. De meest gebruikte isolatiemethode tot nu toe is een hele simpele eigenlijk. Je hebt een buis, daaromheen komt isolatie, daaromheen komt een stukje cladding. Het kan aluminium zijn, het kan roestig staal zijn. Het kan een kunststofmateriaal zijn. En wat je dan ziet is inderdaad, komt er eenmaal water in, dan kan het er eigenlijk heel slecht weer uit. En zal zich heel vaak ook op de oppervlakte van die buis gaan settelen. En daar heb je dus precies dat CUI risk. Nou, wat zou daar eventueel aan gedaan kunnen worden? Non-contact isolatie. Zoals je hier ziet, zit er een spouw. Kijk of jullie kunnen zien wat ik doe. Ik denk het niet. Nee. Deze dan. Maar nu wel. Hier zie je dat er een spouw zit tussen de mediumbuis en het isolatiepakket. En dat zou kunnen voorkomen dat water op die buis blijft liggen, waardoor dat het de coating kan aantasten en uiteindelijk roest kan veroorzaken. Hoe ziet dat er in de praktijk uit? We zijn niet op een buis, maar op een apparaat. De non-contact isolatie. Een andere methode die ook regelmatig wordt toegepast is deze, de Duitse variant van de non-contact isolatie. Alleen wat erg opvalt is dat nu de spouw aan de buitenzijde zit. Dus wat we in het filmpje in het begin hebben gezien, dat water wat zich in de isolatie kan verzamelen, op een gegeven moment door de warmte van de buis weer naar buiten gaat. Maar in dit geval slaat de damp eigenlijk aan de buitenzijde tegen aan de binnenkant van de beplating aan, waardoor dat naar beneden kan lopen en via de drainhole weg kan. Dat wordt hier nog eens een keertje in het kort het een en ander over uitgelegd. Dat snel zijn, jullie kunnen nog altijd terugkijken. We zijn inmiddels een kwartier over tijd. Wat hoopt KAEFER uit te halen uit het CorrosieLab? Nou, wat wij hopen is dat wij een bijdrage kunnen leveren in het voorkomen en het bestrijden van CUI. Wij hopen dat jullie kennis kunnen nemen van de uitdagingen die wij als isolatiefirma voor onze kiezer krijgen. En we hopen ook jonge mensen die bijvoorbeeld op Scalda zitten, geïnteresseerd te maken in het hele mooie isolatievak. Dat was het voor wat mij betreft. Ik sluit de presentatie en dan mag Rutger het verhaal weer overnemen.
Dankjewel Ben. Zijn er op dit moment vragen voor Ben?
Zijn er nog mensen? Oh, ja.
Zeker wel, zeker wel. Goed, nogmaals, alle informatie, de presentaties, filmpjes, contactgegevens, we proberen zoveel mogelijk op onze website beschikbaar te maken. Dan krijgen jullie ook even een e-mailtje over waar die te vinden zijn. Dus dat volgt later deze week. Als er interesse is in het CorrosieLab, eventueel om deel te nemen, zoals Ben en KAEFER dat ook op dit moment doen, neem gerust even contact met mij op. Ja, en ook gezien de tijd, ik denk dat het een goed moment is om af te ronden. Ben, hartelijk dank voor jouw presentatie en je ervaring. En also Claire, thank you for sharing your knowledge and wisdom regarding corrosion under isolation. Iedereen die aanwezig was, hartelijk dank. En houden we ook vooral even de agenda in de gaten voor de komende webinars van KIK-NPI. Er komt nog veel meer rond corrosie onder isolatie en vanuit het praktijklab. Bedankt, fijne middag en tot de volgende keer.
Dank jullie wel voor je tijd en hier voor je aandacht.